finished our Year 11 content. We are going to jump into our Year 12 content for algebra. The first thing we're going to look at is solving simultaneous equations by drawing a graph. Now, when we solve simultaneous equations, we have two methods we can solve them: graphically or algebraically. We're going to talk about graphically. So here's an example question. Solve the simultaneous equations 2x minus y equals 4 and 6x plus 2y equals 12 graphically. So how are we going to do this? To answer this question, we have to graph both of these equations as straight lines, and we're going to use the point gradient form. Very important. We're going to use y equals mx plus c. Y equals mx plus c. Very important. So we're going to rearrange each equation to match this formula. So how are we going to do that? The first one we have is 2x minus y equals 4. Now we need that to match our formulas. Now you guys can't tell me how to rearrange these. Feel free to write them in the chat how you would rearrange them as I work through them. But I'm going to run through the working for you now. Actually, we'll do it on this slide so you don't see the working straight away. So the first thing we need to do is get y by itself. So actually I might run through it here. We're going to remove the 2x from the front and put it to the back by subtracting 2x from both sides, which ends up leaving us with negative y equals 4 minus 2x. We then need to times each side by minus 1 so that we just have y. We can't use negative y in a y equals mx plus b format. This cannot be a negative. That will be incorrect. It has to just be y. So we're going to times everything by negative 1 to get a positive 2x, negative 4, and a positive y. Other side, 6x plus 2y equals 12. We're going to move the 6x by subtracting it from both sides, which leaves us with 2y equals 12 minus 6x. Now we can't have a 2y. Again, look at our formula. Y equals mx plus b, not 2y, y. So we're going to divide everything by 2 to get just y equals negative 3x plus 6. Okay, I'm going to show you the step-by-step working of this question. Please do it with me. We're going to go over it over a couple of different slides. Okay, so number one is set up your page. I'm going to give you guys a couple seconds to get some form of paper in front of you and have some axis drawn. So you need a vertical axis and a horizontal axis. And I want you to pop some markings on them and label one as x and one as y. Horizontal will be x, vertical will be y. Okay, so once we've done that, we want to have some markings on them. Now going back to our formulas, notice that the numbers are quite low, 2, 4, 3, and 6. We don't need a high axis. We're going to go to 8 on our vertical y-axis, and we're going to go to 4 on our horizontal x-axis. Now, it doesn't have to be the same on each. It just has to be the same on the entire x, and then the same on the entire y. X and y don't have to work on the same intervals. Okay, so we're going to graph the first line. Y equals 2x minus 4. First thing we're going to do when we graph a line, which part is the y-intercept? Y equals mx plus b. Negative 4 is the y-intercept. Negative 4. Now we're going to use the gradient to mark 2 or more points from the y-intercept. So our gradient is 2, which means that the rise over run, for every 2 points we rise, we only run 1 point. So I'm going to rise 1, 2, run 1 point. 1, 2, 2, run 1 point. 1, 2, see how this is 2? And this is 1, run 1 point. Now we have a bunch of different markings on our linear model that represent a rise over run. Remember, if your gradient is in a fraction, whatever number it is, it's over 1. If your gradient's 4, it's 4 rise, 1 run. If it's 5, it's 5 rise, 1 run. When you do this, you have to be careful. Just because this is only one box and this is only one box, it doesn't make them even. That is 1, but this is 2. So you have to pay attention to what these intervals are. So we draw a line. we now have a line y equals 2x minus 4. Now we need to mark the second line. We're going to find the y-intercept of our line. So let's go back here. What was the y-intercept? 6. So we're going to go on. We're going to mark 6. What's our gradient? -3. Now what's the difference with gradients? Some are positive, some are negative. This is a positive gradient, the one we just did before, because it was a positive 1, or 2, sorry. This is a -3. Negative gradients run from top left to bottom right. So now we're going to mark points where we go 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So 3 rise, 1 run. So we're going 1, 2, 3 across 1. 1, 2, 3 across 1. Very important. Each of these little triangles will create the same gradient, which is a rise of 3 and a run of 1. 3 over 1, it's a negative. -3 is your gradient. And now we draw those two lines. The final thing we need to do, we've drawn our two lines, is find the point of intersection to solve them. The point of intersection here is 2x 0y, because this is 0y and it's on 2 positive x. So we write 2, 0, and we put it in brackets. So now that we've used this information, we can substitute these numbers into our current formulas to double check they solve each equation. So our point of intersection was 2, -0. Let's have a look at our first formula. So our 2 was the x, y was 0, so we sub that in. 2 times 2, we're going to put that in brackets, minus 0, which is where the y was, equals 4. Is that true? Yes. The next one, 6x, which is now 2, plus 2y, which is 0, equals 12. Is that true? Yes. So we've substituted our point of intersection of the two lines, which is where the lines are solved, into our original equations that we didn't change into y equals mx plus b. We've substituted in 2x, y 0, and the equations still work. Okay, we've now solved this equation. X is equal to 2, y is equal to 0. Okay, now it's your turn. Solve the simultaneous equations x plus y equals 10 and y equals 2 plus 3x graphically. So here are your key steps. Number 1, rearrange the formulas to fit y equals mx plus c. 2, graph them using the gradient and y-intercept. 3, find the point of intersection, which is your solution. And 4, check your answer. So I'm going to give you guys 30 seconds to jot that down, and then we're going to go through the solution. If you need more time to attempt this question, that's fine. Based on the pre-recording of the lecture, I'm not going to give you guys too much too much silence for me or time to work stuff out, because you can come back and do it. I want to give you guys as much explanation as I can. Okay, let's go through our key steps here. So the first thing, we're going to rearrange the formulas to fit y equals mx plus c. So y equals mx plus c, remember it could be plus b or plus c, both are correct. X plus y equals 10, y equals 2x plus 3x, y equals 2 plus 3x, sorry. So how are we going to get y on its own? We're going to subtract x and add it to the other side. Then we have y equals 10 minus x. How are we going to get this worked out the right way around? No need to change. It's already correct. It doesn't matter that the y-intercept comes before the gradient, because they're still both present. Now this step should at the beginning take about 5 minutes to do. By the time you get to your exam, hopefully you're more like 3 minutes on this step, but you're going to graph them using the gradient and the y-intercept. The last step is to find the point of intersection. So if we have a look at our two lines, we should be able to see that one of them was a positive gradient, if we look back here, and one of them was a negative gradient. This is a negative gradient, -1x. The gradient was -1. This gradient was 3. This y-intercept was 10. This y-intercept was 2. have a look at these and see where each of those pieces of information come in. So now that we've had a look, let's run through how we find our point of intersection again. Sorry guys, I felt a sneeze coming on there. I didn't want to cut myself off halfway through. So let's look at each of our lines. Let's take a guess of which one was which. We have an intersection of 10 on the blue one. I'm going to assume that's y equals 10 minus x. And this one we have y equals, let's have a look back, 2 plus 3x. Those are our two lines. The point of intersection, we need to find what x point it's on. It's on x2. We always write x first. It's on y8. 2, 8, we put it in brackets. Our point of intersection, our solution. Now we double check our answers. X plus y. X was 2, y was 8. Yes, it equals 10, correct. Y was 8 equals 2 plus 3x. X was 2. 8 plus 2 plus 3 times 2. Yep, correct. These are both correct. So we know that this point of intersection was correct. I'm going to give you guys just a second to write that down. Okay, let's have a look at some practical problems that we can apply simultaneous equations to. So what does break even mean? Break even mean. What does break even mean? Okay, there we go. When we look at these practical problems, we look at all these lines, look at all these graphs, what do they even mean? This is a very common graph that uses two graphically plotted simultaneous linear equations to graph profit and loss and revenue and cost and sales and units and all of that stuff. So when we look at these kind of financial graphs, we refer to the break-even point as the point where costs equal income. So say you produce appliances, right? And it costs you a certain amount of money to produce appliances and you sell them for a certain point. At some point, the amount of money that you spend producing them is going to meet the amount of money that you've made selling them. That's your break-even point. That's the point where the money that has left and come back into your bank account is technically zero. You've spent the exact same amount of money that you've made, so you haven't made a profit or a loss. Below that point, it will either be a loss, or above that point, it will either be a profit. So this is an example question from one of our books, our Unlimited Standard Maths book. Archie organizes a fundraiser for Beyond Blue. The fixed cost is $2,000, as well as an additional $20 per person who attends. Each person attending pays $60 per ticket. Draw a graph to represent these equations. A, what is the break-even point and what does it mean? And B, how much profit is made when 80 people attend the fundraiser? So before we even attempt to draw our graph, which have a look, we're looking at the fixed cost of $2,000 for an additional $20 per person who attends, and each person is going to pay $60 to attend. We need to find the straight line equation for both sets of information. So we're going to write out two equations. The first one is equation 1. This is the cost of the fundraiser. So the setup cost is $2,000. Now, why is this the y-intercept? Because before the fundraiser even happens, he will have spent $2,000. So if this is our line, right, which with these graphs, we actually just start on this side of the line, positive, we don't have any negative. We're going to start at $2,000 because you're not spending zero and going up. You're literally spending $2,000 off the bat. Then there's the additional cost of $20 per person. That's our gradient. So our first equation is going to be cost equals 20 times the number of people who come, which is x, representing our gradient, plus 20 is our gradient, x is representing the number of people who come, and $2,000 is our y-intercept, our fixed cost. The second equation is the income earned by the fundraiser. The income earned is $60 per person, which is just going to be I equals 60x. No need for a y-intercept. So this is what our graph would look like. Now, why don't we have this one, or this one? Because there is no negative amount of income. There's no negative number of people attending. So there's no need to have anything except this quarter. Okay, first equation. Find the y-intercept in the gradient and rule up the cost line. So the total cost was $2,000 off the bat, and then we rule in how much it's going to cost per person. So if 10 people come, it's going to cost an extra $200. If 20 people come, it's going to cost an extra $400, so on and so forth. So you usually want to plot about 4 to 5 points and then draw a line through all of those points so you get a very accurate line. The next thing is I equals 60x, our income formula, which is I equals 60x because it's $60 per person who attends, and x is the people who attend. So we're going to start at 0 here. We're going to draw a straight line based through all the points that we draw. Now we should recognize what that is. That's our point of intersection, our break-even point. So everything below that point in here, this is all loss. This is where the fundraiser makes no money and is actually losing money. This is all profit. So our break-even point is 50 people or $3,000. If 50 people attend, we will have spent exactly $3,000 and made exactly $3,000. Okay, so we can plot it out and say this is profit, this is income, cost. It occurs when 50 people attend. So we need to go back and answer our questions. What is the break-even point? What does this even mean? The break-even point is when 50 people attend. When 50 people attend, the cost is $3,000 and the income is $3,000. If more than 50 people attend, he'll make a profit. If less than 50 people attend, he'll make a loss. We're going to check this answer using both equations. So we've established on our graph that the break-even point occurs when there are 50 people attending. So now x equals 50. So we're going to substitute in 50 and we get $3,000. And when we have I equals 60 times 50, we substitute in here $3,000. Both of those equations are correct. So B, how much profit is made when 80 people attend the fundraiser? It's important to remember, profit will equal income minus the costs. We therefore need to calculate the income when 80 people attend and minus the costs of 80 people attending. So income when 80 people attend is 60 per person who attends times 80 people, $4,800. The cost of 80 people attending is going to be 20x plus 2,000. Remember, that's our upfront. That's how much it costs per person. Substitute in 80 is going to be a cost of $3,600 to run the fundraiser when 80 people attend. Okay, hopefully we're all following so far. So we're going to calculate the profit. Profit equals income minus costs. We subtract 3,600 from 4,800. We get $1,200. So if 80 people attend his fundraiser, Archie will raise $1,200. Okay, here's an example question. A footwear company produces items whose costs are $300 plus $18 for every pair of shoes produced. The company sells the shoes for $110 per pair. Write an equation to represent the relationship between the cost and the number of items and the income and the number of items. Okay, so the first thing we're going to do, and I'll just check if I've written out my solutions here, yeah, is write our two equations. Cost is going to be $18 for every pair of shoes produced, the X, plus $300, which is just an upfront cost. The income is going to be $110, which is the cost of purchasing the pair of shoes, times the number of shoes that are purchased. We now need to draw these onto a graph. So have a look at our y equals 18x plus 300. This is our cost. Our intercept is 300. We draw out a line for $18 per cost of each pair of shoes being developed. Our income always starts at 0 because you don't have any intrinsic income, times 110 for every pair of shoes sold. Now we can find our break-even point in here, which is a little hard to see, but it's about 3.5. You can't sell 3.5 or 3.25 pairs of shoes. You need to round up so that it's 4 pairs of shoes needs to be sold for the company to break even.